ATV Forum that pretty much changed to digital now. I was told that we should call this a Digital ATV Forum because I would get more attendees, so that we'll see. But we've got just
What
little...
you do, raise your hands, see how many people thought this was an analog versus a digital.
Yeah, is
That'll
anybody
tell you
that
real
thought
quick.
that this was all analog as opposed to digital? No?
Okay.
So that, well, actually, it's both. We emphasize toward digital, but it's also analog. And that I normally have Gordon West give a couple introductory statements, but seeing he isn't here, we got to do something to wake up the crowd. Sure.
Could you use the mic?
Oh,
Yeah.
It's on.
is it on?
Oh,
Yeah, it's on.
You can take it out the stand.
I need to be a little closer to it here. Is that any better? Okay. I appreciate it. So that, first of all, I normally have Gordon West. He's usually wakes up the crowd, but and I'm usually introduction as far as the forum or as far as the our Zoom conferences are concerned. Usually have a joke of some sort, and that not quite sure how to tell a joke at this particular time. But in order to start things out a little bit, I'll ask the crowd, do you know what is brown and sticky? Anybody know what's brown and sticky? Nobody knows?
I look at it twice a day.
Oh, okay. Well,
You're lucky.
well, you're wrong. It's a stick. It goes downhill from here, I think. So that, anyway, I'm WA8RMC. My name's Art Towsley. I'm from Columbus, Ohio. We have the ATV repeater in Columbus. And because we're in Dayton, I'm told that I was presented with this nice ATN shirt. So they said, you've got to be an ATN person when you're around here. So I said, well, okay. Seeing I was presented with the shirt, I think this is a good time to wear that. First of all, we normally have Gordon West to give us an introduction. And then when he comes in, or if he comes in, that we'll let him take over. But in the meantime, that we've got the first person is Mel Whitten K0PFX. He's going to do an introduction to digital television. Mel is from the St. Louis area. Been in ATV for a long time. And then we got Mike Collis WA6SVT. He's the ATN network. He's a network broadcast engineer from Los Angeles, California, so quite knowledgeable in television. And he's going to do the features of the amateur television network in California, which is quite extensive. And after that, I'll do a wrap up. I want to do a small introduction of the Digital ATV Receiver. Just mention it quickly. I'm not going to do a big talk on this one, but I've designed a new digital amateur television receiver. Multi-frequency, multiple ID. It's computer repeater compatible. There's a number of advanced features on it. It's all based on the Raspberry Pi. So I just wanted to mention it. I've got some sheets about it here. And at the end, we'll maybe talk a little bit about it if time permitting. But that's all I want to do is just introduce it at the stage of the game. It's in the design phase. I've got the hardware design. We've got to finish up the software before we have a complete product. But it will be a product for sale.
Approximate price?
Approximate price has not been set, but it will be under $200 for the complete receiver. The engine is Raspberry Pi, so anybody that knows Raspberry Pi software will be able to make modifications because the code will be open source. So open source code is a non-profit type of thing, so we're not supposed to make any money on it. Any money that we do make on this product will be go into the purchase of parts for the next project. So yet to be defined. So enough on that.
He's already got one of those.
What's that?
You got the DATV Express board with the transmitter.
Well, the DATV Express board I designed as a transmitter board that it was used primarily in Europe. The sales dropped off enough on that one that we've discontinued operation or discontinued publication of that. Can bring it back if the need be, but also did a mini tuner type of thing. It's a receiver that works in conjunction with the computer. But this particular product is a standalone type of thing, so you don't need a computer with it. So that's the advance there. Okay, with that, Mel, I'll introduce Mel Whitten, and let Mel take it from there. Or you want to just use your
snag
computer?
another computer.
Okay. We'll just put that one down.
All right.
Set that one there and put your
There you go.
HDMI input right there.
Oh, shoot. I don't think I'm gonna have a problem.
You got an HDMI?
Yeah, over here.
Okay.
These are both Lenovo computers, and they've got the connectors on the opposite sides. And bring it up here.
There, it works.
All right. Oh, well, there we go. My name is Mel Whitten K0PFX, and as Art mentioned, I've been in ATV for some time now. Have a repeater in St. Louis, and built from scratch. And I'm a proponent of the high definition digital ATV. So that's what I'm going to be talking about today. Versus the DXing, which can be done with digital as well, but at a different bandwidth. So let's get started here. So the topics today will be on a digital video broadcasting for ATV. This is a European mode. I'll talk a little bit more about that protocol and what basic equipment you'll need for transmitting and receiving digital ATV, and how to configure your station, how to get it on the air, and I have a couple of pages of resources. Our talk will be on the SLATS ATN .NET repeater, probably next week or so if you'd like to download this presentation. So amateur television is a wide bandwidth, so obviously you have to watch where you put it. But it can be used on 70 centimeters and all higher frequencies. The most popular one is 70 centimeters down near the bottom of the band. You can have a 70 centimeter repeater from 2 to 6 megahertz. They're mostly used 2 and 6, although there are in between. The one we have in St. Louis is actually 4 megahertz because of coordination requirements to get a repeater, an in-band repeater where you have the transmitter and the receiver on the same band. But a lot of them are split. Like in California, for example, they'll have one frequency on 1.2 gigahertz. So what is this DVB-T? Digital Video Broadcasting Terrestrial is it's a European standard. It's been around since 1998. It's worldwide. Actually, the protocol that we use here is in the United States is limited just to the United States and a couple other countries. And why do we use it? Because of the lower modulator and transmitter costs. It's very expensive to have an ATSC transmitter like we see on our TV today. It has a relatively low received signal noise that's needed, making DX possible when you go to a narrow bandwidth like 2 megahertz. Remember the old analog ATV is 6 megahertz wide, and you couldn't change that. It's excellent in multipath, which is a big problem. And mobile performance works quite well if you want to run it mobile. There's a variety of equipment available from a manufacturer in Taipei City in Taiwan. And this all follows an open standard, as I mentioned, from the UK. So this is not my display here for how to show digital signal advantage, but again, when you're looking at high definition, it definitely has an advantage over the old analog signal. As you can see, I have a locked picture clear down to what's called P2, which would be a very noisy picture on analog. There is a relatively steep knee though, but with the sensitivity of some of the receivers, it still works quite well, even in the wider bandwidths that we're using now. Again, to mention DVB-T is worldwide. Everything in blue is DVB-T. The green is the US protocol, and it's now up to 3.0, and of course ultra high definition, or what's sometimes referred to as 4K, is coming on strong now. So a typical station, you'd have a high-def receiver, or a high-def TV camcorder, and fed right into a DVB-T modulator or transmitter through HDMI cable. Then after that, you probably need a little bit of power. Most of our modulators run relatively low power, so a linear amplifier of around 10 watts is what most people use. Now on the receive side, you may need a preamp, and then into the receiver. Out, put HDMI, again high def, into a video monitor. So it's a fairly simple setup, although to actually interface all this together, you start running into a few issues that I found, and we'll discuss how we got around those. So what do you need to get started? HiDes incorporated the DVB-T receiver and transmitter is what a lot of us use. A small linear amplifier, 70 centimeter antenna, a camera, and a laptop. Now, depending on your area, you need to find out if you have a repeater in there and what frequencies they are using, as that will determine what model of receiver for HiDes that you would want to purchase. But I'm looking at the lowest cost ones that work on 70 centimeters. And so who is this HiDes? They're a Taiwan manufacturing company. They do a lot of digital video equipment, broadcasting, surveillance, a lot of signage. They would use their transmitter to send out to a bunch of television monitors, say throughout an area like here, and that saves on running RG59 or coax to all of them. But they have a lot of products. They speak good English, and all of their documentation is English. And they have a very good technical support package. A lot of us have used them to make and request changes, and they're very open to those changes. So we've had really, really good luck with them. They've been around for a number of years. You can find them on eBay as well. Again, they have a lot of products. The transmitter and receiver we're using is called an HV110. I got one of those that I want to pass around. If we can get started back over here. Just give you an idea of the size. The DVB-T receiver is the same size as the transmitter, very small package. It's a standalone, just plug in an HDMI connector and power and away you go. On the transmitter side, you can see on the back there is what you call a UART connector that connects to your PC for configuration. And once you have it configured, then you can remove it. The receiver itself is configured with the OSD on-screen display remote. Well, some of the specifications I mentioned is a high definition, although it'll do analog as well, clear down to 480 or less. High definition video at 1080p by 1920 or 1920 by 1080p, and you have a variety of bandwidths from 1 through 8 actually, but the most common ones are 2 and 6 megahertz spectrum bandwidth. It uses coded orthogonal frequency division modulation, OFDM. This is a multi-carrier system modulated with quadrature phase shift keying. OFDM is the same thing as like you use with your Wi-Fi, and a lot of other digital products use OFDM. It's very popular. There's some of the frequencies from 170 to 1350 megahertz for the transmitter, but the receiver will only go up to 950. So if you wanted to do 1.2 gigahertz, you would have to update the receiver to a later model, like a 120. The transmitter power is relatively low, but there's specific amplifiers built just for this mode, which will give you 10 watts output, class A. It allows use of older technology. You can plug in your older analog camera into it, and it'll convert it to a digital output. And the receiver also includes a video recorder, so you have your own personal recorder. You see something on the air, just push a button and you can record that. To set up the receiver with the handheld remote, as I mentioned, it's very simple to set up. Really, all the receiver needs to know is what your bandwidth, 2, 4, 6 megahertz bandwidth, and of course what frequency. From that, it will receive transmit parameters from the transmitter to set up the other requirements for decoding the signal. On the transmitter side, you have some software that you run to set it up. It looks rather complicated, but the software itself is for a wide range of products, so most of this doesn't apply, but obviously you have to tell it what bandwidth and what frequency and what modulation you're going to use, and how much forward error correction that you may need, and then the output of all of that will then give you the bits that it's going to run at, which will in turn determine what mode of high definition or standard definition that you can run. Yes?
Are there ham standards that are being used within those setups?
A standard?
Yes.
Yeah, well, yeah, there is. There's not, I don't know, Mike would say there's a written standard, but in each location, like in St. Louis, we have a standard for ours, and our network is set up for 4 megahertz, for example, and that's what everybody runs, yeah. But point to point, you could run others, yeah. But we have a website where we define all of our parameters, and therefore a new user knows how to set it up to get started.
Thank you.
Here's what the signal looks like on the oscilloscope. It's got a flat top display. There's many carriers in there, several thousand carriers running at a low baud rate, like 50 baud or so. You combine all those together with a inverse fast Fourier transform. It's all done in mathematics and computers, and the output is FFT. It converts it back. The typical configuration looks like this, as I mentioned: receiver, high def television, receiver. Then on the transmitter side, camera in, and you can use either a camera or a laptop, or use your a camera on your laptop itself. although a camcorder probably works the best for you, and out to an amplifier, and into you have to have a fairly heavy-duty power supply for this, because this is going to be on maybe for several hours at a time. A typical antenna, you can possibly use a vertical. That's all going to depend on, like any other mode, where you're located to the station that you're going to be working. Yagis work quite well for this mode. And to put all this together, I found that since the transmitter and the receiver have no on and off switches, it's kind of inconvenient to plug them in and out to be able to turn them off and on. So I came up with this little interface, which also includes an antenna relay. So it makes it very simple to go from transmit to receive by just flipping a switch up and down, and also to be able to turn on a preamp. I've got one of those here you can pass around and give an idea of what you, again, this isn't required, but it just makes operation of ATV much simpler. Again, it's just basically switches and some connectors on the back, which you plug your transmitter and your receiver into, and then it'll switch between the two. Yes?
Have you had any experience using iPads or iPhone?
iPad or iPhone? Well, yeah, as long as you get an output of HDMI out of any device, yeah. I'll talk about that in a little bit here. So anyway, you can see on the back that we have RF in and out, and we have DC in and out, and a push-to-talk control if it's needed to turn your amplifier on, and of course the antenna out. So it's fairly simple to do. There's a picture of it, again, that's being passed around. There's a couple of more things on there. A lot of the really good relays are military relays that run 28-volt coils, and we're basically a 12-volt crowd. So there's these little DC to DC converters for $3 or $4. So I use one of those to control the relay. And then to stop any, you can have a problem of hot switching if you turn it off immediately. You still have RF output across your contacts. So there's a delay circuit, a little PC board next to it, and it's basically an RC circuit, so it turns that relay off later after the power's off your transmitter. And if anybody wants to build one of these, I have plenty of these boards. It's a layout that I did several years ago, and fairly easy to build. And again, it connects right to these, like a Tasco relay. You'll see a lot of those in flea markets here in, and also on eBay. And they range from $25 or $30 or so. But they're very good relays. They're excellent. Had very good luck with them. The optional may need a preamp. There's a couple of them available, one from KH6HTV. We found also this one from, has a bypass relay in it from VHF Design. Unfortunately, they're from Ukraine. Although their website's still up, we don't know if they're going to still be manufacturing those. But it worked quite well, and we want to use a preamp up by the antenna, which is, of course, the best place. Otherwise, the preamp from KH6HTV worked quite well too. And Down East Microwave also makes one that works fine. So when you get finished up, here's what your station looks like. You have the transmitter and receiver. You can stack it right on top of the controller. The amplifier on the right is KH6HTV's amplifier. It runs about 10 watts, but it's also good for the other modes. You can use it on sideband and even AM as well. So that would be a good one to purchase. I believe they're going to be available. He got wiped out in the fire in Colorado, unfortunately, but there are other amplifiers available. Specifically made for high-des equipment. I'll pass those around, and I'll also pass around this LNA or this preamp. They're very well made. All the construction of them, I've been using them for about 5 or 6 years now, and they've been just great amplifiers. We have no problems at all with either one of them. So typical for cameras, you can use the same type of camera that you use for any of the modes, other, like Zoom or something like that. This camera here is very popular, a Logitech 910 or 920 camera. The better camera to find, if you can get one, is, what happened to that one? Yeah. Is a camcorder from Canon. I've had really good success with those. I've had a couple of them. And of course that allows you to record as well. But you can record on the receiver as well. So let's look at, so we can get some video here and audio. Not sure.
You have a question back there.
All right, just a second. There we go. Got some audio here. It's going to come up or not? Yeah, what was the question?
Is the audio chain integral with this? If you plug an HDMI in that's carrying an audio?
Yeah, the audio's on HDMI. You can also put it in separately, but HDMI, it's MPEG, it's good audio, it's stereo. Yeah, great audio. So let me run a little video here of a digital ATV signal, a QSO in progress. This is using a high-des ATV setup, and it's also recorded on a high-des receiver.
That same tower, that's what they call it, the community tower. You know what I'm talking about? About 1,100 foot tall.
He's not very loud, is he?
No, I don't recall. Gee, I can't think of the name of it. I used to go there all the time, and that's where Channel 11 has their antennas on the tower.
No, it's not.
Channel 11.
That's an actual
I think
transmission?
General
Yep.
FM station.
Yeah, it's not bringing audio. He's talking about, you can see the
All the combiners.
very excellent picture. This is 1920 by
It's
1080p.
all shooting up one major.
And he's talking into a camera,
power
I
device.
guess it's about 3 foot away or something like that.
It's just amazing.
N0GL, and he's about, 20 miles away or so. And again, this was recorded using the high-des HV110 receiver.
What's your capacity?
So, once you've played around with your camera a little bit, maybe your PC, you're thinking, well, what else can I do with this? So if you have something like an HDMI switch, you can use that to provide different inputs into your transmitter. You may want to add a media box, for example, and have some canned video in that. Or you might want to, if you have a DVR, like a security system, you can connect it to that and show your cameras around the house or wherever they are, in-house, in the shack, and so forth. So it's very versatile in that, in the fact that you can add any input you want because it's HDMI. So here's some examples of adding additional video content, as it's called. All of these inputs are directly into the transmitter. You can see there's a screen of your television or your PC, at 1080p. There's one camera I got looking up at my tower. Here's the one on my tower looking out at a field behind my house. And of course you've got pictures that you can pick off the internet as long as they don't violate the DCP rules. So there's a lot of stuff. A NASA channel can be played back at any time. So there's a lot of other things besides this, but that's just a few that a lot of people have found popular to do. So digital ATV, it always has a good picture. I'm not sure who coined that, but it definitely has a good picture. And There's a lot of resources for it. As I mentioned, Jim Andrews, Amplifiers and Application Notes. He has some very good notes about how to get on ATV, how to set up a repeater, how to set up your station. So that probably would be one of the first places I'd go to if I was getting started in ATV, is Jim Andrews' website, k86atv.com. Of course, we mentioned Hi-Des. They also have a website for their business, but you can find them on eBay, of course. And the Amateur Television Network, another resource, atn.tv.com. And in St. Louis, we have a website there with there's a number of technical articles in there that I've written that you may find helpful if you're getting on ATV for the first time. And some videos and overall activity that's going on in the area can be found on the website. There is a Digital ATV group. It's an IO group. It's not very active, but sometimes it is. But I think there's a lot of people listening on that group. So if you have some questions, that'd be another place to go. And recently they got their own talk group on DMR 3196. So if you're on DMR, that'd be another place to look. The British Amateur Television Group has a lot of information on ATV. There's a lot of repeaters in Europe, a lot of analog, but digital as well. And they're using the QO100 satellite. Unfortunately, we can't, and also running digital TV through the satellite. Sorry. Yeah, good one. OE7DVH, Darko, who designed the amplifier that I'm passing around, that's been a very good amplifier, a real workhorse for us. A lot of people are using that one. There's a couple of books on digital television. The one by Mark is probably one of the best. It's kind of hard to find. And also a third edition of that one is another good book on digital television. They're several years old, but that's fine because we're using DVB-T and not T2, the latest stuff. So I think you'd find those very helpful, at least I have over the years. So we have any more questions about digital TV? Yes, in the back.
What's the largest micro SD card you can put?
32 megabytes. Mm-hmm. Yeah, and that'll record a lot of video. The recorder, unfortunately, they don't have a real-time clock in the receiver. So you have to go by, it does have a unique ID, but the times that shown, they're just kind of random times. So you have to go by a unique ID for it. Yes?
I have two questions. First, are there FCC regulations as to the content that you can broadcast?
Yes. No porno. Yeah, you can't, obviously, you're not supposed to use anything. It's copyrighted. But other than that, it's, again, this is amateur radio. So, no advertisements, don't show everything on eBay, things like that.
So that precludes music?
Yeah. Yeah, just like the voice, so, yeah.
The other question is, how, I'm trying to visualize the environment in which people are going to connect with each other using this. Do you have to have a group of people all in agreement, okay, we're going to use this frequency and we're going to get on at this time?
Yeah.
There's no
Basically, that's
CQing on video.
It's usually set, at least with a repeater, by your state coordinator as to where you can put your repeater. So once that's established, it's in their database, so you know where the repeaters are. As far as getting together, most areas have what they call a talkback frequency on a different frequency, like 2 meters. So say you're transmitting to me, and I want to talk to you, interrupt you, I pick up the 2 meters radio and I talk to you on talkback frequency. 144.34 has been very popular. Or you may have a repeater, you could do that as well. Or if you're full duplex, like some of them are, you can talk back and forth. Yes?
What are the requirements for setting up a repeater?
Gee, first thing you want to find is a frequency that you can put it on. Yeah, I think Mike's going to talk more about repeaters, so I'll let him answer any questions you have on the repeaters. Because he set up a lot of them. I only set one up. Okay, yeah, in the back.
Amplifier you had. You make some comments on linearity of amplifiers.
Any what about?
When you were going through your slides, you skipped over Jim's amplifier as part of the system. Would you make some comments on the linearity requirements for amplifiers?
Yeah, remember that slide I showed you of a spectrum analyzer? Yeah, that's the best way to set them. Because if you overdrive it, it'll start spreading out, and you'll have problems. Your quality will fall down on your signal. The receiver will tell you that as well if you drive it too hard. The receiver has reports of the signal to noise ratio and of the quality of that signal. So you can use those as well. Yes?
Can you still use like a D1010 ATV, that's the big old barrage, 100 watt for
At lower power, I think you can get by using one of those. Mike, what do you think?
I don't recommend them, but
Yeah.
some of the guys are doing it.
Right, yeah. Again, you have that problem because it's not Class A.
Yeah.
You know, your signal starts spreading out.
In
And you have
general,
intercarrier distortion, you know, all those carriers, so your quality will start falling off and your data drops, you know, so. It's probably not a good idea, but like Mike said, some people do use them.
But if you
Run
do-
them at, you know, 5 or 10 watts, you
If you
know.
view your picture back on the other repeating frequency, you could adjust the power output of the amplifier to.
Yeah. Remember, these have very low output, the transmitters in the milliwatts, so I don't know if you could drive that 1010 without a little more power, right?
We're
Mike?
making an RF parts,
Yeah.
type of, little intermediate, transmitter, I should say, little amplifier.
Yeah.
RF parts still make that stuff?
Yes.
On the West Coast?
Yes, they do.
Yeah, they
yeah,
do.
the brand.
Yeah.
Okay, so yeah, there's stuff you can do to make that work.
It's doable.
Alright.
Especially if you have a spectrum analyzer and you can look at it, so.
Okay.
Just one comment, if you wanna use a D1010 for your own personal stuff, probably all right, but don't try and put something like that in the repeater. If you're constructing a repeater, you don't want something like that because of all the spurs and this intermodulation products that a D1010 has, so beware. Repeater, no. Individual, yes.
Yeah. And we have no one in our area that's using one, and that's the reason why. So, yes.
What's your initial cost on a basic station?
I'm sorry, what?
Can you get like a ballpark cost on the station itself?
Yeah, I have one slide of that. The receiver is $119, and the transmitter is $279.
And then plus another amplifier on top.
And the amplifier, you're gonna add another couple of $100 for that. $220 with the one chip. The one I showed you, I think is about $400. It has multiple power ranges. Class A amplifiers are a little bit harder to find. On surplus, Mike's found a lot of them that we've used.
Basically $500 to $1,000 depending how well your junk box is
Yeah,
outfitted.
yeah, 500 to 1,000 for a station.
Your Q5s are pretty clean.
Pardon me?
Your Q5 amps are pretty
Yeah,
clean.
yeah. Okay, any further questions? Yeah.
ATSC, that's our TV
Yeah,
system.
yeah.
Have you tried anything, direct on that? Why did we,
Because of the
why did we go to
transmitter.
the European standard when we
Yeah,
got our own here?
Well, they're limited to 6 megahertz.
Well, basically ATSC 1.0 sucks.
Yeah,
That'll
yeah.
answer your questions.
Right.
What do you mean? We
It
watch
doesn't work
every night.
global. If you go more than 5 miles an hour, it doesn't load, it doesn't work. The exciters are very expensive, although there's some signage systems that use it, but it's That's why US is going to 3.0, which is using the same OFDM.
Yeah.
It's similar to DVB-T, but we moved too quickly. And for home use, for fixed home use, it's okay, but.
They use that virtual sideband, that
But
8-channel.
your TV news
Yeah.
helicopters and the mobile vans all use DVB-T. They don't use ATSC 1.0 because it's that bad.
Yeah, it's the OFDM.
It's
that makes it
politics
work.
that
Yeah.
got involved.
Yeah.
Because Zenith had a lot of money in the receiver chips and the ATSC committee. It's like anything else, you get a lot of politics involved.
Yeah.
And so technically, for us, for what we do for portable public service, this is a better format for us. And equipment's cheaper. So,
Like
there
I
you go.
recently bought one of those mini mods, Mini Mod 2. I don't know if you've seen those.
Minimod what?
I bought a Mini Mod 2 distributing TV around my house. But I mean, it generates, every format there is. They're about $350, $400.
Oh, yeah, I know what you're talking
Yeah, the
about.
little black one.
Yeah, right.
I just wondered why, we didn't try something like that. And
They're limited to 6
seems
megahertz.
so
Yeah,
easy, you
6
go right into the
megahertz.
receiver.
They're limited to the bandwidth. That's what's great about the high des. They're agile in their bandwidth. They'll go clear down to 1.5 megahertz. That's what they're using over the satellites. Can't do that with anything else. I gotta go, guys. Thank you.
You can leave that loose, I'll grab it.
Okay. I would like to have my stuff back.
Your receiver's right there.
Okay, thank you very much, Mel. Appreciate it. I realize that it's difficult in the time frame that we've got to be able to present a good example of how to get on DATV and ATV in general. But bear with us and that ask a lot of questions. There's a lot of stuff out there. So I think Mike's going to fill us in on some of the other stuff. What's that? Okay, I'm sorry. Next up is Mike Collis WA6SVT. Sorry, Mike. And that he's broadcast engineer in Los Angeles, California. Quite knowledgeable and everything. He's going to fill us in on the ATN network in Southern California.
Okay, where's your, go ahead, we're talking about this, for frame.
Well,
You using theirs or is this yours?
no, this is mine here.
Or I can have you operate the slides. Oh, okay. We're using Art's computer, so. So if you could operate that, if you, where all your keys are at for that. Anyway, I'm Mike WA6SVT out of Southern California, and I work for one of the major networks in LA is my regular job. And I mean, I should say ATSC 1.0 does a good job for home TV sets. It's just not good for portable. And that's why the new format 3.0 is going to be able to work for cell phones, portable devices, as well as TVs at home, and have the ability to run up to 4K transmission. So it's a much better format, but that's a whole nother story for, but not for today. Okay, Laura, we have we're not on the screen yet. Something timed out. Projector, I think.
Projector's off there.
Projector's off. Oh, you just touch the power switch perhaps? Don't you hate when this happens?
Never worked with this before, so I don't really know what I'm doing here.
Yeah, see, they make the machines too complicated, even for us ATVers.
I don't know whether anybody else knows
There you go, got green light, it'll fire up. You got the, on the correct,
This,
yeah, but it's still not input. You gotta change the input button to probably A.
it's,
Yeah, it was on input B.
Oh, it was on B?
Yeah.
Are you plugged into the right terminal on your computer?
yeah, there's only one,
Otherwise, you might have to move this to Mel's computer.
oh,
Now that the projector's on.
There we go. All right. That's up, up and down this laser and left and right is.
Right, yeah.
Okay. Let me get going here. Well, yeah, what is amateur television? It's a network of ATV repeaters nationwide. That's our club, Amateur TV Network, and each area has their own chapter, such as there was a separate club of Slats, which is now part of ATN in St. Louis that Mel's involved with. Dayton Amateur Radio Club works with ATN, so we have the DARA chapter, and then there's chapters in Arizona and all over the place. And this is going to be a presentation of linked ATV repeaters that are in Arizona, Southern California, Nevada, and there's other areas that have linked repeaters as well, but this is by far the largest system in the world. This is Mount Wilson. We figured we'd put this in to kind of show you that our signal's so hot it even catches the forest on fire. But this is Mount Wilson, and our ATV repeater is right here. The transmit antenna's right there.
Too close to one.
Yeah. I have the lights on. I'm working up here with this burning, and I've got a fire suit on and everything else to keep the transmitter on the air. It got within 1 block of the building. It just looks worse than it is. And there's the Los Angeles area, and this is the Pacific Ocean, and of course the moon and all the haze there. And then of course the pictures also help the public service to know where the fires are at. Southern California, we have a repeater at Santiago, which is the hub or the center repeater. We have Mount Wilson, which you just saw, Oak Mountain Snow, Jobs Peak, and Santa Barbara. And then we have a link going out to Nevada. Frequencies. Some of you folks were asking about frequencies. In Southern California, Arizona, Nevada, Florida, and some of the other southern states, 434.0 is the frequency to use. You could use either an AM transmitter or vestigial sideband filters about 1/3 of the lower sidebands off, so that instead of being 9 megahertz, it's 6, but cutting the lower sound and color and a little bit of the visual off. If we're going to run DVB-T, we'll use 2 megahertz bandwidth, and why is that? Because we want to stay out of the 431 to 433 weak signal part of the band, and the satellite 435 to 438. You say, well, how come not on the vestigial sideband or AM? Because with an analog AM type signal, most of your power is at the video carrier and the oral carrier. The other sidebands are almost insignificant. The narrow receivers never know you're there unless you're like a block away. So that's how we've been able to do that for years. Also, all the repeaters have 2441.5 and FM input on the 2.4 band. And in the case of Santiago Peak, now all these repeaters, whether in Nevada, Arizona, or California, use that format. It makes it easier for the users to get equipment. In the Midwest and some parts back east, the old 439.25 is more popular. Output frequencies for Santiago, 1253.25 vestigial sideband and 5910 FM. We do plan to go DVB-T output on Santiago Peak, but we need to get everybody with the receivers for digital, or we'll get a bunch of people upset if we switch over and they haven't got their receivers yet. This is the coverage area from Santiago Peak. Covers most of the Los Angeles, San Bernardino, Riverside areas, and covers down quite a bit of San Diego as well. This is the repeater rack, the upper right-hand corner. The actual PA is a 600 watt amplifier running it at 400 watts peak sync. and it's a blowtorch. Below that is the fan cooling system, and then below that's the IPA, another fan cooling system there with the little grid, and then you can see the Cadco modulator. We go DVB-T, that Cadco goes, and we put the little, what Mel showed you, the exciter in. The RF chain is already ready to go, it's all digital ready. Now there were some questions about amplifier linearity. The pre-driver, which is here, is all Class A. The driver, actually I got a laser pointer. Sorry about that. The driver here is one of those RF power modules from RF Parts, which is also the power module that's in the HTV video amplifier as the final. Now at lower output levels, 2 or 3 watts, you're in the Class A region of the amplifier. You can run them up higher and you're in Class AB1. Most broadcast TV transmitters, all the low-level stages are A, the final is AB1 for better efficiency. In fact, the newest thing is a Doherty amplifier system, and I don't want to go into all that. If somebody wants to ask about those, I can do that afterwards. This is the 59, we have a 5910 output, 25 watts on the 5 gigahertz band into a 9 dB Omni. And we use that primarily to talk back to the other repeaters that are all the way around the system, but other users can also look at the repeater output there. Triple monitor, this is an old FLR6 transmitter I converted over to 5910. This is a voder for our receive system, 1286 voice repeater, duplexer, 100 watt power amplifier. This is a 220 repeater we have up here. This controls our tower camera. The analog receivers here, and can't see it, but right as the cord goes back under there is the digital receiver. Up here I have receivers for all the links, and then this one is the 2441 receiver. I put 7 receivers in a 3RU rack, and they just 2 screws pop out. And we're using the same format, so I can take that receiver, a spare receiver here, say on 2441, I can plug it in Nevada, Arizona, any of the California repeaters. So it's a modular system. It's the only way. I don't have the time to run all over the place with everything different, so we keep everything the same. And then with our video links, we have 2 audio channels on the links. We use one, that's why the voder system, so both the 220 repeater and the 1200 repeater, we have receivers at some of the outlying repeater sites. Put that on the second audio channel, run through the voder. You have a wide area coverage voice repeater system, because like they talked about the 144.34, that works great, but when you're covering 200-300 miles out, you're beyond the range of most people's simplex 2 meters, so we have to use that type of system. Plus we can also control the repeater. Moving on. This is another shot. This is the duplexer for the 220. I built this out of some transmit cavities, so it's a 4-cavity pass notch. Designed this using a network analyzer, and then these are just bandpass. So it's just a side view of what we already talked about. This is our Oak Mountain site, and believe it or not, I have 643,000 miles on that. Transmission doesn't slip and it doesn't burn oil.
Must be a Ford.
No, it's a Chevy. It's called maintenance. Here's the coverage of Oak Mountain. This is our 8-foot link dish back to Santiago. Now, in the old days, we received the 1253, so this is a backup link now, frequency, but we transmit 2417.5 back to Santiago, and this is a custom-made dual feed horn. And this is up at about the 25 or 30 foot level on the tower. This is the view, and this is the Oak Mountain is the only repeater left that we have in the 900 band, 919.25, and we're probably going to change this to 1241.25. The interference, even though we're running a 1/4 kilowatt, all the Part 15 interference, especially since Southern California Edison decided to put 100 milliwatt essentially Wi-Fi type transmitters and all the power meters that pulse every minute or two. It's a mess. And this is the 3380 FM transmitter. We're only running 10 watts and get about 8 to the antenna, but we can get out 40, 50 miles on 3 gigahertz band. And in our group of all of our different chapters of ATN, we worked with the FCC, and we were able, with others that also filed, we were able to save part of the 3 gigahertz band. So we are allowed 3,300 to 3,400 with new transmitters. Anything above 3,400 is only the existing transmitters until the 5G licenses get put out for that area, for that part of the frequency band, and then they have to move off. But at least we didn't lose the whole band, but it's a whole other subject. Here's the tower at Oak Mountain. This is our 434 receive, and also it's the master receive for all the 70 centimeters on the site. This is the 1200 repeater. That's our voice repeater antenna there, and can't quite see it, but the 2.4 antenna little whip is up. It's right there. It's up on top, and our transmit antennas are on the back. This is the new rack setup here. We're in a new building out of the old building. And then again, that same plate like you saw at Santiago, we can drop the receivers in, and we got it there. Here's our controller. We got video screen and audio. We put all the monitoring in. And this is using the ATV R4 controller board from Intuitive Circuits. Here's the analog receiver on 434 and the digital receiver on 434. This is the 3.3 transmitter, one of our bandpass filters. This is the 1/4 kilowatt on 919 and the power supply for it. Snow Peak. Notice we're running the same input frequencies, but the output is DVB-T. This is our first output. And we're running 4 megahertz. Why not 6? Because we had to deal with radar. It was on 1246.7 megahertz. When we were running an analog output, when they reshuffled the radar frequencies, our oral carrier was every so often tickling a radar facility almost 100 miles away out on San Clemente Island. So we had to put a reflector to minimize the radiation that way, because this is primarily used for the desert, even though it covers back into LA. Here's our 1242 transmit antenna here on the very top of the tower. Here's our camera, receive antenna, and link antennas are, actually that's our 6-foot link dish back to Santiago Peak. And we use the same 2417. We do frequency reuse. Works perfectly good with FM for the links. And because it's FM, we have much higher resolution than analog AM television. So we can still support 600 line resolution with the FM links. Here's a picture from the camera, and this was a big fire, and in fact here's right below, and getting ready to come up to the site. Because we were able to provide this, they were able to get a crew up and protect the site. Not only because we're there, because the building next door has got Riverside County in it, and they didn't want to lose their fire department radio, so they sent a crew up. But we were given the visuals, and they oh, we got to protect our stuff. So sometimes it's good to, you know, help out with public service. This is with an infrared camera at night. Here's the coverage of Snow Peak. Covers clear down past the Salton Sea, clear down into a little bit into Mexico, almost to Yuma, and covers the Palm Springs area and out towards 20M Palm, Yucca Valley, and then there's some scattered coverage back in LA. Mount Wilson, same receive, same as all the others, and then we have 1265.25 residual sideband. This will probably be our first repeater we convert over to digital output.
And all these are vertically polarized?
Everything's vertical. It gives a nice smooth radiation pattern. We typically can get more gain in the horizontal polarity antennas, and we don't have the icing problem that sometimes, like, I mean, you could, if you really work at it, you can do good horizontal antennas, but it takes up a lot of real estate, and they're physically fairly large compared to the verticals. This is the channel, the KCAL channel 9, and then this is the backup antenna for KCBS. The main CBS is 1,000. It's a skinny tower here, but it's actually 1,000 feet. But our antenna, repeater antennas are right here at the 200-foot level on the tower. You don't need much to cover LA. You just need to get about the trees and other stuff. And we're right out on the point, so we don't have any other towers blocking the path. Here's the coverage of Mount Wilson. It does a lot of the same things Santiago Peak does, where Santiago will cover up in here, Wilson will not. And then Wilson covers part of the San Fernando Valley, but not the whole area. That's why we have ODE. So sometimes mountains help us, sometimes they don't. So you usually have to run multiple repeaters. You get the best of both worlds. Here's Job's Peak. This, I should have put in the background picture of my house. I didn't. This is like a 2 or 3 year old presentation. I changed a bunch of slides in it at the last minute. Again, same thing with the input frequencies. And you see that, oh, that's the same with Santiago. How does that work? Well, we're using a cardioid antenna because the way I've got it mounted on the tower, and I'm able to reduce the radiation more than 30 dB towards the Santiago coverage area. And this is primarily to cover the high desert, Victorville, Lancaster, out towards Barstow, stuff like that. This is the view from where the repeater antenna is at, and also above that is my dual Yagis for 434. This is Lake Silverwood. This is Hesperia in here, Victorville's here, Quartzsite Mountain is here, Edwards Air Force Base is right out over there. This is El Mirage Lake. LA is the other, towards the oceans the other way, and Interstate 15 runs here, and Las Vegas is out that way 200 miles. Here's the coverage from my place at Job's Peak, so it covers the high desert fairly well, and I actually have some coverage on the LA side as well. Except, like I said, with the cardioid pattern, I reduced this radiation so it's insignificant to not bother the Santiago coverage. Santa Barbara repeater. They don't have the digital receiver hooked up yet, but they still have analog 434 and 2441.5, and then they're out on 1289.25. And this is raw WB9 KMO. This gives you an idea. This is a 10-foot diameter link dish, 124-mile path with a slight blockage from a ridge. Not quite line of sight. We're 7 feet short. If we could take a bulldozer and take off on Calabasas Peak and take 7 feet off the top, we'd be line of sight. So we put 30 watts on 2417, that magic frequency again for links, and we literally blast and knife edge the signal off the ridge to get a decent picture back to Santiago. And with our 400 watts, most of the time it's P5, sometimes P4, but they get to 1253 quite well. Here's the coverage area of Santa Barbara, because our other repeaters don't really cover well up there. Here's the racks at Santa Barbara. That's the picture from Santiago Peak of a ridge in the line and a 124-mile path. And that's just picking up the Omni. Now if you notice, there's some of you maybe remember an AM signal. You get the crosshatch between the sound subcarrier and the color. You don't see any of that. That's because the amplifier we're using is so linear, and we're using a vestigial sideband cable TV modulator. It's just as good as the AM broadcast that you used to see on, commercial TV. So it's quite good. Here's a view. This is Santa Barbara and their harbor down, and then there's some other part of the city down over here I didn't show. This is our link site that ties us into Las Vegas. We got a lease from the BLM, went through all the permit process, had to haul 5 yards of concrete by Sacrete up to the site because you can't quite drive it all the way up, and the cement truck won't go up there. So we mixed 5 yards by hand to get the tower foundation. It was a lot of work. And that's somebody right there. And we're not quite done. We've got to put more zigzag. This is all done now. This is just taken when we were constructing the tower. A little later, we got the zigzag done. Here's an 8-foot dish back to Job's Peak, and here we're using a 5 gig link back to my place and 5 gig from my place back. This is a 10-foot grid. It's the same antenna you saw in Santa Barbara, and we're receiving 2417 from Mount Potosi, 103 miles away, and transmitting 2417 to Mount Potosi and receiving 1265 FM for our dual link. This is our tower here, and this Edison's a little closer to where this picture is, the Southern Cal Edison Tower. You'd think they'd have electrical power. No, it's all a solar only site. Yeah, okay. And then this is our Arizona stuff. Same input frequency, there's a coverage there. This is Mount Lemmon near Tucson, and the coverage, the tower, and some of the racks there. And then there's our link map here, tying to all the different sites. This is just and then this by place, Ord Mountain, and then Potosí's over here. And if we link later to Arizona, we'll go from Snow Peak over towards Kingman, Arizona, and then down to White Tank. And that's it. Thank you.
The next group's ready?
Yeah, that's it.
All right.
Yeah, they're running.
Oh, I can turn that off. You just turn that switch on. Yeah.
Well, thank you very much. Appreciate all the participation. And you'll notice that Mike has got a very, very early stage primitive arrangement there. Everybody else should be much better than what he's got. Right? Yeah, there you go. Well, that represents a lot of work and a lot of equipment and a lot of time and effort. So that hands-on for the ATN group out in California. That's about it. I was going to talk maybe a little bit about my receiver, but time is of the essence, so we'll bypass that. If anybody has any questions, the booth is what, 3014?
1003, 1004.
1003, 1004, I'll have it at that booth. And that I've got a little data sheet as to how the receiver works and what the specifications are and so on. So stop by and we'll discuss it a little bit further. Other than that, enjoy the show. I think we've got a good crowd, and that if not before, we'll see you next year. Thank you very much.
I'll be out the back door for a few questions. So if you want more details, then you come over to the booth. All right, thank you. Okay, Art, I'm just going to be out the door in case some people have some questions.